All right, in this video, we're going to continue section 3.1 when we talked about measures of central tendency. Those were like mean, median, and mode. And we're going to talk about something called a trimmed mean today. So first of all, what does a trimmed mean? Well, the word trim sort of means to cut off. So like if you trim meat, well, you're going to cut off the ends or cut off the fat or something like that. So you kind of precisely trim it. All right, so if we're talking about a mean, what that indicates is we're going to actually sort of trim off some of the data values. So we're going to calculate the mean of the data values remaining after trimming a specified percentage of both the smallest and the largest values from the data set. So maybe we're going to trim off 10%, or maybe we're going to trim off 5%. So that might indicate we're going to knock off, the biggest two and the smallest two. And the question would be, well, why would we want to do this? Why are we going to ignore some of our data by trimming it off? We're essentially ignoring it. Well, the biggest reason why is if we have outliers. So an outlier would be an extremely big or an extremely small value that would throw off the average of the rest. A good example of this, when we look at our next example here, skip ahead here. We saw this confirmed cases of COVID-19 when we did this on the previous video. And when you look at these number of active cases, which is this column here we looked at, there was a lot of zeros, 3, 7, things like that. But there is one that's really big, and that is here for Newark, the zip code 343055. That is Newark, which is way bigger than all the other ones. So when we're calculating the average, we'll see how much that could impact. Whereas if maybe we trimmed that one off and then trimmed the smallest one as well, that might give us a better picture of what the true mean of this data is. So that's why we would want to do a trimmed mean, is to eliminate outliers. Outliers can affect the mean. So if we have some big outliers, we might want to trim some off, and then that might give us a better pictures of the true mean. So how we're going to do this, we're going to talk about, in this case, just a 5% trimmed mean, but we will compute a 5%, a 10%. We'll look at a 20% trimmed mean as well. So how we're going to do this, and this would be the same for any trimmed mean, it's just the 5% would change to a 10 or 20 or so forth. The first step in calculating a trimmed mean is to order the data from least to greatest. So just like we're going to do a median, we would order from least to greatest. Oftentimes you'll be asked to calculate the mean, median, mode as well, so it might already be the case. So order it from least to greatest. We're then going to delete the bottom and top 5% of the data. This could be 10% or 20 as well, but it's important to note that we do both the top and the bottom. So delete the 5% of the top and 5% of the bottom. So we're actually, in this 5% trimmed mean, we're actually eliminating 10% of the data because we're taking 5 off the top and we're taking 5 off the bottom. Same as if it were a 10% trimmed mean, we'd actually be taking 10 off the top and 10 off the bottom. So we'd actually be eliminating 20% of the data. All right, and how we're going to do this, deleting the top and the bottom 5%, is we're going to multiply the sample size. So let's say we have 30 data values as our sample size by 0.05. So the percent as a decimal. So if it was 10%, it'd be 0.1. And we're going to round to the nearest integer. Not necessarily rounding up, but we're rounding to the nearest integer. So if we get 1.2, that's going to be 1. Or if we get 3.8, that would be 4. So we're going to round to the nearest integer. We're then going to subtract this amount of data values from both the top and the bottom. So let's say we get 1.7, round that up to 2. So we're going to take 2 off the top and 2 off the bottom. So we're just going to cross them out and not even consider them. And then we're going to compute the mean of these remaining values, whatever we have left over. All right, let's go ahead and do this. There's a lot of words there, but the actual process isn't too bad. So let's go ahead and take a look at a couple examples. We're going to use 2 of the same examples that we used the other day. First of all, the confirmed cases of COVID-19 for Lincoln County, and this was from September 22nd through October 22nd. And we're going to look at those active cases. And I went ahead and ordered them there. So we're going to do two things. We're going to compute a 5% and 10% trimmed mean, and then we'll actually compare it to what we got when we did the original mean as well. So the original mean that we got when we did this first time, X bar, remember that's the symbol we use for mean, was 10.79. So just keep in mind that's what we got before. And let's go ahead and calculate the 5% and 10% here. So for the 5% trimmed mean, we're going to multiply the number of data values. In this case, there's 24 counties, or zip codes, sorry. So we're going to do 24 times 0.05, the percent as a decimal. When we do that, we get 1.2. And then so we're going to actually just round that to 1. Oops. So that's approximately 1. Which means we're going to trim 1 off the top and trim 1 off the bottom. So we're going to go here and we're going to X the biggest one off and X the smallest one off. And then we're just going to compute the mean of all of this leftover data here. And we do that just by finding any mean. We would just add them all up and then divide by the number of data values. So when we do that, I'm going to just write this X bar trimmed. That just means it's a trimmed mean. You don't necessarily have to write it that way, but so my trimmed mean in this case, we'd add them all up. And when you add up all those, excluding the biggest and the smallest, you actually get 152. And now be careful, we're not dividing by 24 because we eliminated 2 of them. We're actually dividing by 22 now. And that would give you about 6.9. Sorry. So the 5% trimmed mean would be 6.9. So you can see if we compare it to the original mean that we got, that was 10.79. So that lowered the number of cases a lot just by eliminating, in this case, mostly that 107 was a really big outlier. So that sort of brought up the overall mean a lot. To calculate the 10% trimmed mean, it's going to be very similar. We're going to do 24 times, in this case, 0.10. So when we do that, we get 2.4. Nearest integer is 2, so it's approximately 2. So we're going to knock off 2 from the top and 2 from the bottom, starting with our original. So we're going to knock off this one, and then we knock off 46 and 107. So then we're just considering the mean of all of this without the top 2 and then without the bottom 2. So we're essentially eliminating 4 of the data values. All right, so then our trimmed mean is going to be, add up all those, you should get 106. And since we took off 4 of the data values, we're going to divide by 20. And that gives us 5.3. So it lowered it even more because we eliminated that 46, which is a pretty high number. So you can see how this would be beneficial because that 107 really skews the data. It brings up the number of cases, makes it look like the mean is a lot more than it really is. So it is helpful to do these trims and means in certain cases when we have big outliers. All right, and then the other example that we did the other day, we'll look at here. This is the polling data that we talked about. I'm looking at the percent for Trump and percent for Biden in Ohio. And we're going to compare 20% trimmed means. The original means that we got for this, for Trump, we got his original mean was 48.64. And for Biden, his original mean was 46.67. So let's see how much those change or if they change. Now you'll notice on this problem, there isn't really any huge outliers. There's, when we order them, I'll show you here. Get these. All right, so when we order Trump, there isn't a ton of really big outliers. 55 is kind of an outlier because it's 3 above the biggest one. So you could say maybe that one's a little bit of an outlier. 43, not really an outlier on the bottom side. So there wasn't really any crazy poll, so this might not have much of an effect, but nonetheless, let's go ahead and see how it works. So for the 20% trimmed mean, we're going to do the number of data values. In this case, there was 28 of them times 0.20, if you want to. And that is 5.6. So that rounds up to 6 because that's the nearest integer. So that means we're going to chop off 6 from the top and chop off 6 from the bottom. We'll do that 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. And then we compute the mean of everything that's left over inside here. Make sure you are ordering these. I already did that. So just make sure you're doing that. You're not just whacking off, 6 from either side without ordering them. That would give you wrong results. So with that, now we're going to calculate the trimmed mean. When we add up all those, I should get 778 divided by 16 because we had 28 and we eliminated 12 total. So it leaves us with 16. And that gives us a mean of 48.6. And you can see it's actually almost identical as the original mean, 48.64. So very, very close. Didn't really do us any good to do the trimmed mean in this case. Let's see if it had any effect for Biden. So the 20% trimmed, actually, I've got to order them here. There we go. So for the 20% trimmed mean, we want to do the same thing. We have 28 data values again, times it by 0.20. We're going to get 5.6 again, which means we're going to eliminate 6 data values from the top and 6 from the bottom. So trim those off. 1, 2, 3, 4, 5, 6. All right. And 6 from the top. And then so we're going to be calculating the mean with all of this left over in the middle. When we do that, we get 751 divided by 16, and that gives us 46.93. So Biden's actually went up just a bit, about 0.26 when we trimmed it off. But again, it was very close to what it was before. Trump's actually went down a little bit by 400th. So really not much effect in this case because there wasn't really outliers on this poll so much. So ended up with very similar results. So that is a trimmed mean. Do your best on that and let me know if you have questions.